Hello, this is Kenneth and welcome to my calculus tutorial. In this tutorial, we will be looking at rate of change. Let's start off by answering the question, what exactly is calculus? Well, calculus is a branch of mathematics that focuses on finding derivatives, and integrals. In the 12U course, we will be mainly focusing on derivatives. So what exactly are derivatives, you may ask? In the most simplest term, we can say that derivatives are the rate of change of a function. Rate of change of a function. Now, the concept of derivatives can be used in many real-life situations. For example, you can use it to find the maximum or minimum revenue a business can generate. We can also use it for optimization, so finding maximum and minimum area of any shape, 2D or 3D. So here is an example question found on page 139, number 10, and we will be able to see how useful the derivative is. A demographer develops the function p at x equals to 12,500 plus 320x minus 0.25x cubed to represent the population of the town of Koutville x years from today. So on the right here is a graph of a function, just to see what it looks like. So let's start by answering question A. Determine the present population of the town. So if we look back at the question to read it again, this function p at x represents the population of the town of Koutville x years from today. So if we want the present population, that means that we need to find year 0. So p at 0 of a function here. So let's do that. Alright, so let's rewrite our equation down here. P at x is equal to 12,500 plus 320x minus 0.25 x to the cube. So if we're trying to find the initial population, we need to find p at 0. So whenever we see an x in the function here, we substitute it with the 0. So that turns out to be 12,500 plus 320 times 0 minus 0.25 times 0 cubed. So that becomes 0, that becomes 0, and we're left with 12,500. So let's write a therefore statement. So therefore, the present population of Koutville is 12,500. So that's the answer for part A. Let's move on to part B. Predict the rate of change of the population in 3 years and in 8 years. Alright, so the key word here is rate of change. Remember at the beginning of the video, I said the derivative is the rate of change of a function. So in this particular question here, we need to find the derivative of p at x. So how can we find the derivative of p at x here? So to find a derivative of any function, we need to use the derivative rules. So because this function here is a polynomial, we can say that the derivative of p at x is equal to the derivative of the first number plus the derivative of the second number plus the derivative of the third number. Let's give it a try. So the derivative p at x is equal to the derivative of the first number, 12,500. Remember, this is a constant, so the constant rule applies. That means that the derivative of 12,500 is 0. The second number, positive 320x, we can simply take the coefficient of x, 320. And for the third number, negative 0.25x cubed, we need to bring down the 3, so negative 3 times 0.25, and we also need to subtract 1 from the degree here, so x squared. So if we simplify this, it turns out to be 320 minus 0.75 x squared. That is the derivative. Okay, let's look back into the question and see what it is asking. Predict the rate of change of the population in 3 years and in 8 years. So to find the rate of change at those years, we can simply plug in the number for x into the derivative. So let's try that out. P of 3 is equal to 320 minus 0.75 times 3 squared. If we work that out, we will end up with 313.25 as our answer. So, therefore, the population is increasing at a rate of 313.25. So we know it's increasing because the number here is positive. So let's try to find the rate of change at 8 years. So P at 8, P prime 8 is equal to 320 minus 0.75 times 8 squared. And if we work that out, it turns out to be 272. So therefore the population is increasing at a rate of 272. Let's move on to question C. When will the population reach 16,294? This question has nothing to do with rate of change, so we use our original equation of P at x, not the derivative. So in the question, it tells us that the population is 16,274. That is our P at x, 16,294. So let's move everything on one side. What will be 0 equals to negative 0.25x cubed plus 320x minus 3,794. Let's multiply everything by negative 1 just to make the x cubed positive. 0 equals to 0.25 x cubed minus 320x plus 3,794. Let's simplify this equation even further to make it easier. We can divide everything by 0.25, and we will end up with an equation of 0 equals to x cubed minus 1,280x plus 15,176. So now we need to find what x is. But how can we find what x is when we have a degree of 3? This is a cubic function. We can't use the quadratic formula to solve for x. So how can we do it? Well, we need to use what we learned from advanced functions and use synthetic division or long division to solve for x. Before we do that, let's recall what the factor theorem is. The factor theorem. So the factor theorem basically states that for a value of x here in the function f at x, when it equals to 0, we can say that x minus that number, so n, that number, is a factor of the polynomial here. So with that in mind, let's try and find a number that satisfies this factor theorem. So that number is usually a factor of our number in our polynomial here with a degree of 0. So we need to try a bunch of numbers, x equals to 1, or plus minus 1, plus minus 2, plus minus 3, and so on, until we find that when x equals to that number, then the equation will equal to 0. So f at x, or in our case, p at x is equal to 0. So once we find the x value to be equal to 0, which ends up to be 14, we can say that x minus 14 is a factor, because of the factor theorem here states that if f at x is equal to 0, then x minus that number is a factor. So x minus 14 is a factor. So now we need to use 14 and use it in synthetic division to simplify this polynomial here. So if we remember synthetic division, we always put the number that we found, 14, outside. We draw a box with the coefficients of the polynomial inside. So the coefficients always are from the highest degree to the lowest degree. So our highest degree is 3, and our coefficient here is 1. So we put 1. Our next degree of 2, we don't have a degree of 2 in the polynomial, so we put a 0. And degree of 1, negative 1280, and degree of 0, positive 15176. So now that we have this, we can work this out. So we always bring down the first number. In this case, it's 1. Now we multiply the outer number here, 14. So 14 times 1 is 14. And then we add them. 0 plus 14 is 14. And then we keep working this through. So 14 times 14 again, 196. And we add these. Negative 1280 plus 196 is negative 1084. Times 14, which is negative 15,176. And if you add that, that's 0. The last number here, or the remainder, is always 0, or you have done something wrong. Now let's write out our new polynomial. So our new polynomial is always 1 degree less from its original. So originally this degree was 3, so now it becomes 2. So x squared, so the coefficient is 1, plus 1 degree less, which is 14x, minus 1084. Now, if we take this polynomial and multiply by our factor up there, x minus 14, if we expand this, it will become the same as our original polynomial here, x cubed minus 1280, x plus 15,176. Now our new polynomial here has a degree of 2, which means it's a quadratic. So we can use a quadratic function, quadratic formula, to find out what x is, because we know that this equation here has to equal 0 because they're factors. looking into this equation here, we already know that one of the x values is equal to 14. Let's use the quadratic formula, find out what the other x value is. So we know that the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. We know that this number here is our a, our b, and our c. So let's plug in these values here. X is equal to negative 14 plus or minus b squared, 14 squared, minus 4 times 1 times negative 1084. And that is all over 2a. 2a. And our a is 1. 2a. So 2. So if we work this out, we will end up with two answers. X is equal to 26.66 and x equal to negative 40.66. Let's go back to our question and see what x equals to, what x means. So x is the years from today. So years cannot be negative, right? So we can scrap this answer here. So now we have two answers. X is equal to 26.66 and x is equal to 14. So these are our two answers. So therefore, the population will reach 16,294 in 14 years and in about 27 years. That's the therefore statement. Let's move on to the next question. When will the rate of growth of the population be 245 people per year? So the key word for this question is rate of growth. So again, we need to use the derivative. So in the question we are given that p prime x is 245. So here's the derivative we found previously. So 245 is equal to 320 minus 0.75 x squared. Because there's only one x here, we can move 320 to the other side and isolate x. So once we move that over, it will be negative 75 is equal to negative 0.75 x squared. So if we continue to work this through, we can divide both sides by negative 0.75. 0.75. And we will end up with 100 is equal to x squared. So x, we square both sides, so x is equal to plus or minus 10. So the question asks, when will the rate of growth be 245? So when? That means we're talking about years again, and years cannot be negative, so we can scrap this out. So therefore, the rate of growth, will be 245 in 10 years. Let's move on to the last question. Is the rate of change of a population increasing or decreasing? Explain. Well, if we look on a graph here of the function, we can see that this is x equals 0, so 0 here's start here. We can see that it does increase and decrease. But what if we didn't have the graph? How can we tell when it increases or decreases? If we want to do this algebraically, we must first consider our original function here. This has a degree of 3, which means it has 2 turning points. As you can see on the graph here, 2 turning points. If we use the first derivative and set it equal to 0, we can find the x values or turning points here. Now, there are restrictions to this. X has to be greater than 0. This is because the turning point here, x is negative, and the years cannot be negative, so x has to be positive, greater than 0. So let's try this out. So we found out previously that our derivative was p prime x equals to 320 minus 0.75 x squared. So if we set that equal to 0 and find out what x is, so we'll bring 320 over, divide both sides by negative 0.75, 426.67 equals to x squared, square root both sides. So we'll end up with the value of x is equal to plus or minus 20.66. Remember, it can't be negative. So positive 20.66 is where our turning point occurs. Now that we have a turning point at x equals to 20.66, we need to find the concavity of it, if it's a minimum or a maximum. Because if we didn't have this graph, it could have been a minimum and a maximum. We wouldn't know which one it was. So we need to do a second derivative test. So our original first derivative was 320 minus 0.75 x squared. So the derivative of that is the p double prime would just be negative 1.5 x. So once we have that, we can plug in our x value of our turning point, 20.66, into our second derivative. P double prime 20.66 is equal to negative 1.5. 20.66. And this number ends up to be negative. Now, if the number is negative, we will have a maximum. If the number was positive, we will have a minimum. So this number is negative, and clearly the graph shows that it's a maximum here. So we can conclude that therefore the rate of change of the population is increasing until 20.66 years, or approximately 21 years, and then decreases. Well, thank you for watching my tutorial. I hope it was very informative, and we'll see you next time.